Okay guys, in this video I'll be doing a revision on the networks chapter, starting from the very first part. First thing we started with is the definition of a network. We said that the network is like a connection between two or more devices by media. When I say media here, I mean with it the way of connection. It can be wired or wireless. It can be wired or wireless. Okay, so again, two or more devices connected by media. The media means the way of connection can be wired or wireless. This is the most easiest definition of the network. Then we spoke a little bit about the infrastructure of the network and the network devices and also the evolution of the network, and this one I'm not going to ask you to remember it for the test. But let's come now to the types of the networks. The types of networks, guys, are specified here according to the size of the network. We have four sizes are defined. The first one is called PAN, which is Personal Area Network. The Personal Area Network have a coverage up to 10 meters. The coverage of the Personal Area Network can be up to 10 meters. It can cover the surrounding devices similar to the one you have at home. You have a router device similar to this one, and all the devices are connected directly to it. It could be also a hotspot, for example, if you're spreading a hotspot from your laptop or a hotspot from your mobile phone to the nearest devices, you can call this one as well a personal area network. The second shape or the second size is called LAN, Local Area Network. The local area network is a little bit wider than the previous one. The coverage for the LAN, the local area network, can be up to 1 kilometer. We can consider a building similar to the one we're sitting in, or a computer lab similar to the one we're sitting in right now, is also LAN, local area network. For example, if you have many buildings are attached together, similar to our school buildings, or hospital, for example, or any other thing like malls. For malls, all the branches of all markets are attached with the same network. Each single one who enters the same mall is going to be linked or getting connection from the same network. We can consider this one also if it's at the same place with a coverage size of 1 kilometer LAN. We can consider it as a LAN network. Okay? I'm going to give you also questions about the abbreviations, guys. So I'll be asking you, what is LAN? LAN stands for what? PAN stands for what? Okay, so PAN again, Personal Area Network. LAN, Local Area Network. The coverage for PAN is 10 meters. The coverage for LAN is 1 kilometer. Third one is Metropolitan Area Network. The Metropolitan Area Network, or MAN, has a coverage up to 30 to 40 kilometer. Again, the coverage is up to 30 to 40 kilometers. In this one, we can make a combination between many LANs at once. So if we have other branches for our school, we can make a connection between all of them in a city similar to Abu Dhabi. It means that we are building a MAN, a Metropolitan Area Network. Or for example, if we have some franchises markets like American Eagle, for example, if we are making a network between American Eagle branches in Abu Dhabi, it means that we are building a Metropolitan Area Network. The coverage here can be up to 30 to 40 kilometers wide. Last one is called Wide Area Network. Wide Area Network, you can give an example of it like the World Wide Web. The coverage of the Wide Area Network can cover like a country or maybe the entire continent. Every single every single connection in the in our continent or in our country, we can say this one is a Wide Area Network because it covers much wide area, and it can carry up to let's say million devices. Okay, let's go now to speak about the network devices. The network devices, guys, are several, and we're going to explain each single one of them separately. The first one is called modem. Modem is a shortcut for modulator and demodulator. So again, modulator and demodulator. The usage of the modem is to make a translation, to translate the data while moving or sending it between two devices. Let's check how it goes between those two devices. If we're sending a file from this device, okay, it goes as a digital signal. What does it mean, digital signal? Anything we can see and understand presented on any digital device, we can call it digital signal or digital data, like an image, like a soundtrack, like a video, like a PowerPoint, like a text file. All of those components, we can consider them as a digital data. But unfortunately, our cables or the ways we use to make a connection between devices, they cannot understand the digital data. So we have to convert it into analog signals so the network devices or the cables can understand them and transfer them easily between the devices. So the modem is responsible for making this translation. The modem is the device that's responsible for making this translation. So again, the data on this device is digital data, and then we send it using the modem device. It's called modulation. So here we are converting it from being digital data to be analog signals, and then when it's received to the other device, the modem connected to the other device is going to do the exact opposite, to retranslate it again from being analog to be digital, so the user can see it in its original shape. So again, the modem works like modulator and demodulator to translate the data between devices, converting it from being digital data on the device to be analog, to be moved inside the network devices or cables, and then retranslate it one more time while it's received in the destination device. Was it clear? Okay. Let's move now to the Ethernet card or NIC. Ethernet card or NIC. NIC is a shortcut for network interface card, and this one is also an exam question. This one is an exam question. The Ethernet card or the network interface card is the card responsible for giving us the way or the capability to get connected to other devices. It can be the shape of this one, the displayed NIC now. Is used, or while using it we are going to get connected using wire, because can you see the place that we can plug the cable, the RJ45, it's at this place, and the speed of the NIC can be between 10 megabytes per second and 1000 megabytes per second. So again, the network interface card, it's like a circuit board connected to our devices to give us the accessibility to get connected to a network, and the speed of it between 10 to 1000 megabytes per second. After that, the RJ45. This is a small plastic piece. We use it to add it at the end of each single cable, the Ethernet cable, similar to this one displayed on the screen, so we can plug it inside the network interface card. So this area or this part, the RJ45, we use it to plug in this place inside the network interface card, so we have a connection between several network devices or several devices like computers, for example. The repeater. The repeater, guys, works to repeat sending the message if we have wide network. For example, if we need to connect between two or more devices and the connection is way further than 100 meters, like it's like far from us, within or more than 100 meters away. So in this situation, we need a device to resend the signal. Because actually the signal moves inside the cables into waves, right? The signal moves inside the cables into waves. And as soon as the wave moves for a long distance, what's going to happen? Yes, exactly. It's going to lose its energy. So it's going to get weaker. While it goes weaker, guys, we have to use another device that takes this signal and resend it one more time with the same power and same direction. That's why we use a similar device which is called repeater. So again, the repeater is responsible for resending the data while we are sending a data between two devices in a wide network if it's exceeding the size of 1 meter. So if the other device is 100 meters away, we need to use a repeater that's going to resend the message to the other destination device. Hub. The hub is one of the most important devices inside the network because it can give us the accessibility to make a connection between several computer nodes or several computer labs or several computer PCs. Okay? But it has one problem. As I told you previously while explaining this lesson, we can call it a snitch. Do you remember why? Exactly. If we are trying to send a message from a device to another, it's going to spread this message to all the connected devices. It's going to spread this message to all the connected devices, not only the destination or the desired device only. Okay? That's why actually it's not commonly used. But if we want to make let's say announcement similar to the one you might be seeing it previously on the board, okay? A broadcast message. If we want to make a broadcast message similar to the one or the announcements Mr. Lee keeps doing on the board, this one can be done using a device similar to the hub. So it sometimes can be useful, but commonly no, we don't use it in our networks. But on the other hand, we use this one, the switch device. Why we are using it? Because in the switch, or while using the switch device, it sends the message to the desired device only. It sends the message to the desired device only. And also, if the message is corrupted, the switch drops this message and send the message to the sender, telling him that you should repeat sending this message one more time. For example, if I wanted to send you an email containing a video, and while sending this email, I switched off my device and the video was still loading. Then on this situation, the switch will drop this message because it's incomplete. It's not going to be sent to all of you. This message is still incomplete. The switch is going to drop it down and it's going to send me a message asking me to repeat sending the full video one more time because it was incomplete. So again, the features of the switch, it can give us a connection between more than one device. It's like suitable.
No.
You have a question? Yes, what is it?
Like the networks in LAN, and it's when I searched it up, it says there's this thing like nano, WAN, CAN, and RAN.
I will be explaining it after the lesson. Okay? Just stick with the PDF for now. I will be explaining the extra things after we finish the lesson. Okay? So again, for the switch, guys, it can give us the same features of the hub, but with two differences. The first one is when we send a message from a device to another, it goes directly to the desired device, and if the message is corrupted, the switch device drops it down. Let's move to the upcoming one, which is a router. The router device can also do the same thing exactly as the switch, because actually most of us or all of you guys are using routers at home, and those routers are connecting between devices you're using, right? So it can give you the same feature with more than this. What are the extra features that the router can provide us with? The first thing is the internet connection. We can access connections outside our network. So again, we can access connections outside our networks, like similar to opening a web page, opening YouTube, using an app. So all of those things, you can consider it as a connection outside our network. Second thing, if you are connecting to a weaker device, for example, my device here, the master device, is so powerful device. Let's say that I want to send a message to any of your devices. If your device is weaker than mine, the router is going to segment the data to smaller sizes so your device can receive it to suit your device, not mine. So again, the router measures the specifications of the receiver device, and if it's weaker than the sender device, it segments or crop the data into small pieces that can fit the receiver device. Was it clear? Is it clear?
Yeah.
Okay. So those are the new features of the router, exceeding the features of the switch device. The gateway, guys. The gateway, this one can be actually a feature that the router can provide us. The gateway is the way, or the, let's say, the gate of our network. If we are going to go out if we're going to go out our network, the gateway is responsible for giving us or giving the devices the IP, the identifiers that we're going to use to reach other devices. Okay, it can be a server, it can be a router, it can be any other network device that we're connected to. Okay, and also it can be like, you have a question? Okay. It can be also a firewall. It can be also a firewall. So here is the shape of the gateway, guys. Let's say, for example, PC4 in this device wants to send a message to PC5 on the other network. So it's going to go as follows. PC4 is going to send the message through the switch device. The switch device by its own, it's going to send it to the server. The server is going to send it to the gateway. It's going to take an IP from the gateway, an external IP from the gateway, and then goes to the other server, takes another IP address or the destination IP address, and then the switch to reallocate the message to PC number 5, or again from PC2 to PC2 on the other network. The same idea. Let's move now to another specification that we can use to assign the networks, which is called network topologies. Topology means the geometrical shape of a network. Again, topology means the geometrical shape of a network. Let's start with the very first one, which is mesh topology. In the mesh topology, guys, we can see all the devices are connected together. All devices are connected together. So each single device of those devices are connected to the rest of the devices inside the network. Let's say this device number 1, for example, is connected to device number 2 and device number 3, 4, and 5, and 6 as well. In this situation, this network can be hardly lost. We can lose the connection in a very hard way if we lost all the cables, right? Which is so hard to be happened. But as a disadvantage for this network is being expensive. So again, this network is like one of the most expensive networks to be established. And second thing, the cabling system. Let's imagine that we have 60 devices. Each single device is going to send or take out 5 cables to the other 5 devices. So in this situation, we might have up to 30 to 40 cables in the same small network similar to this one. It might reach like 900 cables in a network similar to the one we're sitting in right now. We have here more than 30 devices. Imagine each single one of those devices taking out a cable to the other 29 devices. It might reach up to 900 cables at the same place, which is going to be a disaster actually. That's why this type of a network is rarely used. This type of a network is rarely used. We might use it only in ministries or military bases in a places that we don't want to lose the connection. Or if we lost the connection, a disaster can happen. Let's move now to the second type listed. It's called ring topology. The ring topology, guys, looks like a ring, similar to the shape displayed on the screen right now. The data moves inside this topology using something called token, as we explained previously. If you remember, we said the token is a placeholder that holds the data to move it between devices. The disadvantage of using this network, guys, is if we lost the wave connection or if we lost the cable, the entire network is going to be down. The entire connection is lost. And also, if we are sending a message and the token is used, it's going to take a very long time to be emptied one more time, and we can use it to make another transfer. Yes? So again, if we want to make a transfer between devices, this network has to use the token, and if this token is filled, the other devices, if they want to send messages, they have to wait while the token gets empty one more time. The bus topology. In the bus topology, all the devices are connected using a backbone cable similar to this one. All of them are connected to the same line. If the backbone cable went down, the entire connection is going to be down. Okay, similar to the ring topology as well. So if we lost our cable here, it means this network is gone, and also in the bus network, if we lost the backbone cable, the entire network is going to be gone or down. After that, we have the star topology. In the star topology, we must use a device similar to the switch, that we can get connection using it. All the connected devices are going to be connected also to the switch device. This device is going to be responsible for sending and receiving data and organizing the data transportation inside this network. The problem is, if we lost this switch device, the entire network then is going to be down. So again, if we lost the switch device, the entire network is going to be down. But if we lost only one connection, it means only this device is going to be disconnected, but the rest is going to work or are going to work properly. Yes?
Stop. Is it always switch or can it be hub?
It could be hub, it could be router as well, but it's preferable to use a switch. The tree or hybrid or hierarchy network. So again, the last one, tree or hybrid or hierarchy network. Yes, do you have a question?
Why is it preferable to use a switch over a router?
Okay, actually because the router can carry only up to 16 devices at once. The switch device can carry more. Okay? So again, let's move to the tree or hybrid or hierarchy topology. And this one, it's actually a combination between more than one chip. For example, we have here the backbone, which is a bus network, and also the star networks are four other star networks connected to it directly. So again, in the hierarchy or the tree or the hybrid network, we can make a connection between different topologies at once, similar to the one we are having right now, backbone cable, and other star networks connected to it directly. Okay, so far guys, do we have any question? Yes.
Stop. There were something about 10.2. You said it won't come. So we don't study about the 10.
Which one?
Like this.
Previously, no. For the upcoming one, it's going to cover everything I said, everything we took. Okay? So let's move now to the MAC address and the IP. The MAC address, guys, is a unique identifier, and this one is stuck to the devices we are using, even if it's a mobile phone or any other digital device. Let's say we are dealing now with the MAC address related to the devices we're using right now. It's going to be shaped as follows. As you can see, 12 digits separated into pairs. So it means we have 6 pairs. The first 3 pairs on the left side are representing what? Organizational unique identifier. Are representing the organization. That's why they are called organizational unique identifier. Okay? The other ones are representing the serial number, when and where this device were manufactured. The MAC address stands for media access control, and all of those guys are again exam questions. I'm going to give you questions about the abbreviations. MAC stands for what? OUI stands for what? Okay? So again, MAC address is media access control. This is a unique identifier, again attached to the device. We cannot change it. We can identify the device using the MAC address. This is why actually we know this is which device inside the same network. Because using only the IB, we cannot identify which device is using or doing this problem or having this problem or having this error or maybe hacking other devices. This is how we can assure that this is the desired device using its own MAC address. And also, if for example our device is damaged and we want to give it back to the company who manufactured it, in this situation they can recognize this part or this device was manufactured where exactly and send it back to be maintained. Okay, using the MAC address. Let's go to the other identifier, which is called IP address. IP is a shortcut for Internet Protocol address. This one also can be unique inserted, but while using the gateway re-change again the IP assigned to the messages between devices. But internally, when I say internally, I mean inside the same network, each single one will be unique. We have two types of it, guys, IP version 4 and IP version 6. This is the shape of IP version 4, but actually it has to be segmented using dots. It has to be segmented using dots, not colons, sorry. It has to be segmented using dots, not colons. And the values inside those parts, it has to be from 0 up to 255. It carries 32 bits numeric addresses. So again, it has 4 slots. Each slot can carry a number or a value from 0 to 255. Each single one carries 32 bits numeric address, and it has a separation as a dot, not a colon. This is a mistake. This is like a mistake inside the PDF. Okay? On the other hand, we have IP version 6. It can be up to 8 blocks. Each block can contain 4 digits, and each single one can carry up to 128 bits. Okay? Let's move to the difference between the internet and the intranet. We said previously having a connection and having the ability to reach outside our network, we can call this one is internet. On the other hand, if we have a connection internally in the same place that we don't have the ability to go outside this network, we can call it intranet. Okay, the World Wide Web and Mr. or Sir Tim Berners-Lee. Okay, the World Wide Web and the difference between World Wide Web and the internet, guys. The internet are the devices we are using. The internet, we can call it the devices we are using, like similar to the computer devices you're using right now, or any connected devices to a network. The World Wide Web are the things that we are browsing using those devices, like the websites we're opening, YouTube, the apps we're using. We can call those items the www, which is World Wide Web. Okay. Sir Tim Berners, he's a British computer scientist, invented the revolutionary World Wide Web and 3 other things, 3 important things inside. What are they? The HTML. HTML is a shortcut for Hypertext Markup Language. Hypertext Markup Language. We use this language, guys, to design the infrastructure of the web pages, and actually you're going to study it next year. URI or URL. The URI or URL is the Uniform Resource Identifier or Uniform Resource Locator. We use it to identify the place we are reaching on the internet. We're using it to go to reach a specific destination on the internet. So again, URI or URL, again, Uniform Resource Identifier or Uniform Resource Locator. We use it to reach a specific destination on the internet. As you can see, last thing is the HTTP, which Hypertext Transfer Protocol, and this is also identifier to let us understand if this web page is secured or not, if the S letter is displayed here inside the URL we are browsing right now. Let's move now to the domain name system. The domain name system, guys, is also a unique identifier to each single web page we are browsing. But instead of using the IP for the page, we use a name. Similar to the phone book. Previously, I asked you, can any one of you remember all the saved numbers on his phone book? No one can do that, right? So in this situation, we need to replace or to assign a name for those numbers so we can easily remember them. We can easily remember it. So the same can be applied also for the web pages. Instead of using their IP numbers, we can give it a name. And using this name, we can easily reach it. This name has to be unique. we cannot duplicate it. We cannot duplicate it to be used in other sites. Last thing, the DNS server. Okay, the DNS servers, guys, are the servers responsible for carrying the domain names. Let's say, for example, the user is using this device and trying to reach a specific web page. While he's inserting the web page name inside his browser, the browser is going to send a message to the DNS server using the IP, and then the DNS server is going to revert back the website to be displayed in the user screen. That was all what we took during this chapter, guys. I hope you understood everything. If you still have any further questions, please do not hesitate to contact me using your emails.